Hello, I am Puneet Kumar. Welcome to your Pedia channel. Today I am sitting with Dr. Srikar Vulli, who is working as a advanced engineer with Siemens Gamesa R&D at Denmark. Please brief us about your participation with G20 Youth International Seminar in Panjab University and about your lecture on harvesting wind energy.
First of all, thanks for the invitation,
Thank you.
and it's pleasure to be here in this G20 event that is organized by Panjab University at Chandigarh. I would like to thank Dr. Professor Manu Sharma and the Vice Chancellor and all the organizers for inviting me to this event, and I really enjoyed being here. The most important thing is that I wanted to share my experiences, my knowledge in wind power as well as other sustainable energy formats with all the participants. And the objective is to give them an overview of what's happening in rest of the world in these areas and what type of research is happening in various forms of sustainable energy. So I have given a lecture and I also interacted with lots of students. It was pleasure, and I see a lot of enthusiasm among the students. So I think it went well.
During your MTech in IIT Delhi, you have done car modeling for crash and impact loads. Please explain about this work and how much scope is there in this field.
Uh, this was almost like 23 years ago when I started working on my MTech thesis. So the main objective was that uh, we were collaborated with Japan Automotive Research Institute, which is called JARI, and IIT Delhi, and JARI had a collaborative project, so which is what I was working on. And then objective was that we have to find out an optimal structure and design such that it will be robust enough for the impact loads. And JARI has performed several tests in the laboratory in Japan, and they came to us, and I had to set up three different variants of the chassis model and subjected to standard crash analysis, and looked into the different responses like accelerations and deflections and deformations of the chassis, and to find out the optimal design of the chassis. So it's a very interesting field because it involves lots of FE analysis, also both modeling part which was done in ideas, it was in a meshing tool, and then it also has a lot of analysis, dynamic analysis part of this crash analysis in PAM crash. So it gave me lots of hands-on experience working on crash tools and understanding the dynamics and static response to the structure. So it helped me to get my first job in TCS, and besides that, because I worked in very core engineering parts, I also got another 2 or 3 offers because of that.
Okay. You did your PhD from University of Sussex on in-cylinder pressure reconstruction using neural networks
Hmm.
and engine block vibrations. How did you use neural networks for this?
Uh, Again, I need to give a background why this project was initiated by both University of Sussex, and it was collaboratively done with Jaguar cars,
Okay.
and they were funding this, and Jaguar was back then owned by Ford Motors. So the objective was that cylinder pressure information is a key parameter in IC engine control unit, and the thing is that if you want to measure the direct pressure with the pressure sensors, they are quite expensive, and in order to cut down the cost on it, Jaguar came to us and asked us if we could use any of the existing sensors. In this case, it is NOx sensors, which are dirty accelerometers, and they asked us if we could use this information to reconstruct the cylinder pressure. And the available tools in the engineering field back then were neural networks. It's a black box tool, and the objective was that train the neural network with the vibrations measured by the NOx sensor and then extract the pressure from the cylinder. So we have a test laboratory where building neural networks. It was pretty new for me, but it was challenging. But I did some numerical analysis subjects in my master's in IIT Delhi. So it helped me to understand all the numerical parts of it, also least square algorithms and stuff like that. And that helped me to understand the neural network modeling as well as testing.
Okay. How much difficult it for mechanical engineer to use neural networks? What opportunities lie ahead for mechanical engineer in world of artificial intelligence, machine learning, and deep learning?
Well, for me, switching to neural networks, as I said, I did some course in my master's in IIT Delhi, and then it helped me to switch over. But as such, mechanical engineers are good with the numbers. They must be doing a lot of structural analysis, a lot of calculations and stuff like that. So it doesn't require any special knowledge to get trained in neural networks. So I find it pretty easy for me to get into neural networks. So the other parts which you are talking about, artificial intelligence and machine learning, they all are actually synonymously used with neural networks and others. And I don't think in this current world you should differentiate mechanical engineers separately and the artificial intelligence experts separately. Everything is combined these days, so everyone has to understand a bit of everything. And I guess that this is not going to be a rocket science for anyone, and I encourage mechanical engineers to take up this job, get a bit of numerical analysis into their brains and start using it. So it's not at all difficult thing.
Okay. You have designed and developed a 3D model of thermic mount by measurement data while working as research associate in Loughborough University. Why 3D model of a thermic mount is required and how did you do it?
Okay. The background is that the group that I was working at Loughborough University, they have come up with a proposal where when you look at southern part of Africa, in countries like Namibia, there are lots of termite structures, and these countries, when you look at the temperatures, they are like over 40 degrees centigrade, 50 degrees centigrade sometimes, but the termite structures inside temperatures are maintained below 20 degrees. So that's more like a naturally built air conditioning systems. So that was the objective why we wanted to study termites. So the way we modeled it was that we had some machinery which was cutting the termite structures layers by layers. So each layer is scanned, and then we have used medical imaging software where human brain is analyzed using 3D modeling. We use the same software and then built these structural models. Then we analyzed it to understand how the air conditioning, natural air conditioning, is taking place.
You have designed and developed a model for sport welding machine representing the dynamic behavior of the welding machine while working a postdoctoral fellow in Technical University of Denmark. Please explain about this work. Is it vibration based design?
Well, yes, simply to say yes, it is vibration based design. See, the objective was that again it's a company which was interested in it because they were providing lots of spot welding solutions to the customers, and they found that there were lots of defects in the spots that were made by the welding machine. So one of the major factor in that was that the dynamics of the machine, which is actually affecting the quality of the weld. So my part was that build a dynamic model that represents the welding machine and do some kind of sensitivity analysis on it to find out how you could improve the spot welding quality by changing certain parameters like changing the masses, damping and stuff like that. So also do some kind of structural modification to the welding machine. So that was interesting. Lots of experiments were involved and lots of modeling was involved. It was quite an interesting project as well.
Good. How much challenging is it for to do structural analysis of offshore platforms?
Well, as a mechanical engineer or a civil engineer, I think I put these two fields in the same level because we do similar courses like most of the civil engineers, structural analysis. The base concept is always the same. You apply loading, you see the response. So, this is the heart of structural analysis. When you go to the offshore structures, the interesting part is that you have both wind loading and wave loading. And before I got into this offshore structural analysis in Rambol, I was working with wind turbines, and even then it was pretty new to me when I started. Wind loading is something like going as input to the wind turbine, and the response is the loads and the accelerations, the other outputs. So it's like use the same core expertise in offshore structures. So it took a couple of months for me to understand what are the tools, what are these beam element methods and stuff like that. But as such, understanding the concept, it is the same concept. So within 6 months, I became quite an expert in using this Rambol internal tool, which is called ROSAP, structural offshore structural analysis tool, and yeah, it went on well after that.
Okay. Please tell us about latest research domains in the field of vibration, FEM, and wind energy.
Well, I can talk about wind energy first, and I think wind energy is a major contributor to the green transition, and for the next 30-40 years, I think India will see quite a ramp up in the wind research. And I think I suggest, I suggest lots of these youngsters to take up active interest in wind energy field and start looking into opportunities, learning skills, and get to know the field. The opportunities will come on their own because the government is also very active in investing in wind energy, and they will come up definitely. When I compare with 10 years ago and what is it now, it went by fourfolded. With respect to vibrations, I think vibrations is a very generic terminology. So every mechanical design involves vibration analysis. But when you look at a specific level, for example, if you look at condition monitoring, there also vibrations is the major role, and also maintenance based on condition monitoring or structural health monitoring. There also vibrations are quite important. And more importantly, when you look at buildings and bridges and structures, the core area of vibrations, which is model analysis, which comes in place where people can look into the dynamic modes of the structures, even static modes of the structure, and they can work on modifying the structure such that you can optimally design the structure. So vibrations is like a notion of field, and then quite a lot of opportunities, I would say.
How easy or difficult was it for you to leave world of software, TCS, and venture into core technical world, mechanical engineering?
Well, mechanical industry was always my core interest. Just to tell why I left, I don't have anything against software, but I wanted to pursue my interest in mechanical engineering. If I had continued in software engineering, probably I would be earning 3-4 times of what I'm earning now. But I wanted to follow my heart, so I wanted to do a PhD. I wanted to do research in mechanical engineering field. So it wasn't very hard for me to jump from software to here. But as I said earlier, now you can't differentiate. Mechanical engineering is core mechanical engineering.
Yeah.
You have to integrate software engineering, artificial intelligence, big data, machine learning, every field. When I talk about wind industry, it has mechanical engineering, it has data analysis, it has neural networks, artificial intelligence, everything. So look into wider range. So I think I would say when you look your career like that, you can pretty much cover not just software, not mechanical engineering, everything.
Everything. Please tell us the opportunities for engineer graduate in your company.
Let me be honest. For example, if someone wants to come and work in Denmark in our company, it's quite difficult in most. I would say most of the European companies, they don't take masters or experts from India directly. They need to have a European masters or European experience. But when I talk about the opportunities in my company, we do have an office in Bangalore, and it's about a collaboration between, for example, Punjab University and our management. So you need some kind of initiation from the department side and have some kind of interactive sessions with them. But more than that, get to know what the industry requires. If you talk to us, I could talk what my company is looking for, like wind experts, like aeroelasticity, understanding of aeroelasticity, aerodynamics, and also finite element modeling and everything. But if you closely talk to the management, you can get an overview of what the kids needed. And I would say that you need to specialize the kids based on what the industry requires. So skill development is the core thing that I would recommend that university should follow, rather than just going by bookish knowledge.
Is there anything specific that you would like to say it to our student community?
Well, there are few things that I could tell with my experience. One thing is that we seriously lack with our kind of education system in India is that we seriously lack practical experience. So this was my mistake when I did my bachelor's and master's. So I suggest the students always should focus on getting more practical. So I was yesterday telling Professor Gaurav and also talking to the other professors at PU.
Rajesh.
Yeah, he has shown me the green tree outside the department, and it really impressed me. I should say I should appreciate the person who was involved in that. This is exactly what I'm expecting the youngsters to get their hands dirty, start working on. So this is the serious problem with many students from our cultural background. We always focus on learning tools. We are good at mathematics. We very good at solving problems, but the base concept, why we are doing the product development, why we should be doing, we would never know if we don't do things like that. So this is my experience. It also helps once you go and work in the industry. So I suggest all the students to do something practical. For example, yesterday in this speech I was also talking to mechanical engineering students, and I was telling them that you don't need to create a rocket. You just take just like a solar panel and try to create create a plant, hydrogen plant, with a small cylinder. So all you need to do is that get electrolyzers and put into electrolysis system and create hydrogen and use it for gas heating or whatever. This is a base concept. Even I would say that if you go with this concept and meet some investors outside, even in India, there's a lot of support from the government as well. I was talking to secretary from the one of the departments of the government, and she says that whenever you come up with something practical like that, they are ready to support it, which is a very good sign. And this is what our youngsters should be looking in future.
So okay, Dr. Srikar Vulli, thank for your time, and you have given a lot of useful information to potential young mechanical engineers, what they should be doing in future to have a better career prospects.
Thank you very much, and pleasure meeting you too.
Thank you.